Good morning. Next is reactions of alkanes. Reactions of alkanes. In reactions of alkanes, the very important reaction given by alkane is halogenation. Halogenation. We discuss halogenation reaction. What do you mean by halogenation reaction? Reaction with the halogen. Reaction with the halogen. That means chlorine, bromine, or iodine. In halogenation, we discuss the chlorination of alkane. In halogenation, example, chlorination of alkane. Chlorination of alkane. Chlorination of alkane. Okay. We can see that alkanes. Okay, chlorination of alkanes means a reaction of alkane with the chlorine. Alkanes react with the chlorine in presence of UV light or at a very high temperature and will give a mixture of products. So alkanes react with chlorine in presence of UV light or at a high temperature will give a mixture of products. So alkanes react with chlorine in presence of UV light or at a very high temperature and will give a mixture of products. Let us go through the reaction. So, example, we take the alkane methane. Okay, methane CH4 react with the chlorine in presence of UV light. This is the example for a halogenation reaction of alkane. Alkane react with the halogen. Example is methane react with the chlorine in presence of UV light. Look at here. What we get? CH4 means the actual structure of CH4 is like this, and the Cl2 means Cl. During this reaction, what will form? HCl will be formed. So then remaining CH3Cl. So what we get? CH3Cl plus what will form? HCl. This is the first product. So CH4 plus Cl2. Cl2 means ClCl. HCl is formed. Then we get CH3Cl. Now in the next step, we can see that this CH3Cl. What is the name of this compound? Chloromethane or methyl chloride. Common name is methyl chloride. Now this chloromethane will react with another molecule of Cl2. Okay, how it will react? Again I am writing CH3Cl. This is our CH3Cl. It will react with another molecule of Cl2. That Cl I am writing here. Cl. Again, what will eliminate? HCl. So what will form? We get CH2. This Cl is joining here. So CH2Cl2. What we get? CH2Cl2 plus what will Cl2 plus what will form? HCl. That means one more hydrogen atom is replaced by chlorine. One more hydrogen atom is replaced by chlorine, and we get CH2Cl2 plus HCl. What is the name of this compound? Dichloromethane. And in the next step or the next product, you can see that this dichloromethane CH2Cl2 will react with another molecule of chlorine. So what will get? CH2Cl2, how will you write? CH2Cl. How will you write Cl2? Here you can write Cl. Then here it will see HCl is eliminated. Then what will form? CH. This Cl is joining here. So what is that? CHCl3. CHCl3 plus HCl. What is this one? Trichloromethane, or it is known as a chloroform. It is known as a chloroform, or you can write it as a trichloromethane. Trichloromethane is a chloroform. And in the last step, what is happening? This trichloromethane or chloroform CHCl3 react with Cl2. How it will react? CHCl3 is like this. Okay, Cl3, Cl react with Cl2, Cl. So HCl is again eliminating. The last hydrogen atom also replaced by a halogen. So what we will get? C and Cl4 plus HCl. What is this one? Tetrachloromethane or carbon tetrachloride. Carbon tetrachloride. So we get a product, we get a mixture of chloromethane, dichloromethane, chloroform and carbon tetrachloride. Okay. This way, alkanes react with halogens. We get a mixture of products. Okay. Now, the mechanism of this reaction, mechanism of halogenation. Mechanism of halogenation reaction. See, look at it here. Mechanism of halogenation. This mechanism is known as a free radical substitution reaction. Substitution reaction. This is a free radical substitution reaction. Mechanism is a free radical substitution reaction. Okay. The first step in free radical substitution reaction or the mechanism is first step is known as chain initiation step. Chain initiation step. In chain initiation step, the chlorine molecule undergo homolytic bond fission to give free radical. So, what is that? Chlorine molecule undergo molecules undergo homolytic bond fission to give chlorine free radicals. Okay. So what do you mean by homolytic bond fission? That means Cl2 in presence of UV, chlorine molecule will undergo homolytic bond fission. What do you mean by homolytic bond fission in presence of UV? Cl2 means Cl bond Cl, and we know that a bond means a pair of electron. Bond means sharing a pair of electron. So this chlorine and both chlorine will share a pair of electron and it will change into a bond. So a bond means it's a pair of electron. Homolytic bond fission means see here the bond is breaking here. That means both the chlorine will get its shared pair of electrons. So this is homolytic bond fission. Okay, homolytic bond fission. Therefore, this Cl will get its shared electron, and this Cl also will get its shared electron. That means here Cl1 and here it's the Cl with its shared pair of electron. This type of these are known as free radicals. Okay. That means actually it is changing into atoms. Okay, two atoms are joined together to get Cl2. During homolytic bond fission, they will get back their shared pair of electron. That species are known as free radicals. These free radicals are forming in the presence of UV light. When UV light falls on a chlorine molecule, it will break homolytically and it will change into free radical. This is the first step. What is that? Chain initiation step. Okay, formation of free radicals. Now, second step. chain propagation step. Second step is known as chain propagation step. Chain propagation step. In chain propagation step, this chlorine free radicals will attack. The free radicals are highly reactive, as you must keep it in mind. The free radicals are highly reactive. So the chlorine free radicals will attack a CH bond in the alkane to form hydrogen HCl and alkyl free radical. Okay, look at here. The chlorine free radicals attack CH bond in the alkane to form HCl and alkyl free radical. That means look at here. This is our Cl free radical which is formed in the first step, will attack our methane. You can see that methane means CH4, or I can write CH3 and one H is here. Okay, so this is methane, CH3 and one H I am showing like this. Okay, now what is happening? This chlorine free radical will break this bond homolytically, will attack this bond, CH bond. One of the CH bond, and what will form? It will change into H free radical and CH3 free radical. This H free radical and Cl free radical will join together, and what will form? We get HCl plus what will form? CH3 free radical. Once again, so this bond again breaks homolytically. So what will form? Cl free radical, and here what will form? H free radical. Okay, and what will form? CH3 free radical. These two will join together. Cl free radical and H free radical. So what will form? HCl. Then what is remaining? CH3 free radical. Okay, this is methyl free radical. What is that? Methyl free radical. Okay. Then in the not in the next step, but in the next stage. Okay, B. This is A. This can be written as A. Okay. Chlorine free radicals attack CH bond to form HCl and alkyl free radical. B. Alkyl free radical. That means this one, methyl free radical, or generally alkyl free radical will attack another chlorine molecule to form okay, alkyl, or if you take, suppose if we take methyl, particular example is methyl free radical will attack another chlorine molecule to form methyl chloride and Cl free radical. Okay, this is Cl free radical. What is the meaning of this one? Now this methyl free radical, that means CH3 free radical will attack another chlorine molecule, undissociated chlorine molecule. If chlorine molecule is there, so it will attack another chlorine molecule, Cl2. That means how you can write Cl2? Cl2 can be written as Cl. Okay, Cl. Then what will form? This CH3 free radical will attack this bond. Okay, so what will happen? This will change into Cl free radical. That Cl free radical and CH3 free radical will join together. Cl will be formed. Plus what will form? Cl free radical. Okay. And now this step is continuing. This step is repeating over and over again. Okay, Cl free radical is formed. Now it is formed. Now this Cl free radical will attack another bond in the this compound. So that process will be continued. Okay. So this is the second step, chain propagation step. So first the Cl free radical is attacking CH bond in the alkane to give HCl and alkyl or CH3 free radical. Now this CH3 free radical will attack another undissociated chlorine molecule to form CH3Cl. This is our first product, chloromethane. Okay, and what will form Cl free radical. Now this Cl free radical will attack, look at it here, another CH bond, like this CH bond, and it will change into HCl, and what will form CH2Cl free radical, like that it will continue. Okay. And the last step, chain termination step. Step 3, chain termination. Chain termination step. Now, this reaction comes to an end if any two free radicals are joined together. So, the reaction comes to an end when any of the two free radicals combine or join together. Okay, that means the reaction stops when any of the free radicals, suppose if one Cl free radical is joined with another free radical, it will change into Cl2. Or you can see that CH3 free radical is joining with the Cl free radical, it will change into CH3Cl. Or another possibility, CH3 free radical will join with another CH3 free radical and we get CH3. Okay, this type of joining, if the free radicals are joined together, and then the reaction will come to an end. This is the mechanism of free radical substitution reaction in alkane with the halogens. Okay, thank you.